So in the last lesson, we saw how two polynomials, when divided, resulted in another polynomial and a remainder sometimes, not always, but sometimes. The remainder has a remarkable property in a certain type of division. We will explore this relationship in the first exercise. So consider each of the following scenarios. Polynomial term divided by some binomial. In each case, simplify the division using polynomial long division and then evaluate. Well, we're not going to use long division because, well, we just learned synthetic division. Okay, so we're going to use synthetic division and then we're going to evaluate. So I'll show you what that means. So what am I using as my divisor here? Oh, I'm frozen. Oh my gosh, I'm so sorry. Okay. So example A, what am I using as my divisor? If my factor that I'm dividing by is x minus 2, what is my divisor? Positive 2. So positive 2. So let's see. My first term coefficient is a 1. Then I have a negative 8. Then I have an 18. Remember that I bring down my first term and it becomes my multiplier. 2 times 1 is 2. Negative 8 plus 2 is negative 6. 2 times negative 6 is negative 12. Negative 18, 18 minus 12 is 6. So this factors out to, or like the divisor, the quotient ends up being x minus 6 plus 6 over x minus 2, because that's my remainder. Okay, that is my remainder. So the cool thing is, if I use this function and I evaluate it with my root, the root that I'm using is 2. So if I evaluate for p of 2, meaning I'm just going to plug in 2 for x, let's see. 2 squared is minus 8 times 2 plus 18. Let's see. 4 minus 16 plus 18 equals 6, which is exactly what my remainder was. So P of 2 equals 6, which tells you that you have a remainder. Oops, that'd be nice if I could spell that. So the remainder theorem says that you can evaluate the polynomial by the root, and it will equal some number, which becomes your remainder, if you had done long division or synthetic division. So the cool thing about the remainder theorem is that if I want to know if 7 is a root of x squared minus 2x minus 25, I can just evaluate it, right? If I want to know where it crosses the x-axis, I can plug in 7 and see if it works. We're going to use long division first to prove it. Well, synthetic. So my root, if my factor is x minus 7, my root is 7. So I have a 1, a negative 2, and a negative 25. All right, bring down my 1. 7 times 1 is 7. Negative 2 plus 7 is 5. 7 times 5 is 35. That leaves me with a remainder of 10. What if I evaluate the root? Shove that root right into my polynomial. So let's see. My root is 7. So 7 squared minus 2 times 7 minus 25. Well, that's 49 minus 14, which is 35. minus 25 is 10. So P of 7 equals 10. Are you with me, Michael? Okay. All right. So what is the remainder? Is there going to be a remainder, or is the polynomial 2x squared plus 11x plus 11 divisible by x plus 3? Does it divide nicely? What do you think? Well, I don't know. Let's use use synthetic division and see. What am I going to make what am I going to put in the root box over here? A negative 3. So I have a coefficient of 2, a coefficient of 11, and a constant of 11. So negative 3 times 2 is negative 6. 11 minus 6 is 5. You see that you have these right here, right? Oh. Negative 3 times 5 is 11 minus 15 is negative 4. Well, let's see when I evaluate this polynomial at negative 3, do I get a remainder? Do I evaluate it and get that P of negative 3 equals negative 4? 2 times negative 3, the quantity squared, plus, 11 times negative 3 plus 11. Let's see, negative 3 squared is 9. 2 times 9 is 18. 11 times negative 3 is negative 33. So I'm at negative 15. And negative 15 plus 11 is negative 4. So P of negative 3 equals negative 4. Let's try it one more time. How are we going to set this one up? Do you want to do long division since Hannah wasn't here yesterday? Do we want to show her what that looks like? I'll do long division for you. You guys can do synthetic division. Is that okay? So, Hannah, I'm going to set this one for a long division. So, it's just like when you learned how to do long division with regular, base 10 numbers. The divisor goes on the outside and the number that you're dividing is on the inside. You have to ask yourself, how many times or what do you multiply x by to make it equal 3x squared? Well, I have to multiply it by a 3. So it'll give me 3x, and I actually have to multiply it by a 3x. 3x times x gives me 3x squared. Does that make sense? So 3x times x is 3x squared. But this is a binomial, so I also have to multiply 3x by 4, which is 12x. Now, just like when you learned how to take 4 into 27, you knew that 4 goes into 27 6 times with 24. This became a subtraction problem. Reese, open your eyes or you're going to stand up. We have to subtract this. And subtract means that we change the sign. That's all it does. We're just changing the sign. 3x squared minus 3x squared is 0x squared, which is what we want. 7x minus 12x is negative 5x. Minus 20. Okay. What do you multiply x by to make it equal negative 5x? Well, you multiply it by negative 5. Negative 5 times x is negative 5x. And negative 5 times 4 is negative 20. But remember, we're subtracting, so we have to change the sign. Negative 5 and positive 5x is 0. Negative 20 and positive 20 is 0. So this one actually has a remainder of 0. So I know that P of negative 4 equals 0. And what does that mean? That means that x plus 4 is a factor. Negative 4 is a root, or a 0, or an x-intercept. Okay. Are you okay with that, my dear? Okay, turn the page. So when the polynomial p of x is divided by the binomial x minus a, then the remainder will always be p of a. In other words, polynomial divided by binomial x minus a equals the quotient plus the remainder over x minus a. That's just a lot of words for just plug in the root and evaluate. So if the factor is x minus 9, what is the root? The root is positive 9. So we're going to take this polynomial and we're going to evaluate it at 9. So let's see. I have 9 squared minus 11 times 9 plus 22. 9 squared is 81 minus 99 plus 22. 81 minus 99 is 18. A negative 18. Yeah, thank you. Plus 22 is, I don't want that big old bar right there. Is positive 4. So my answer, what is the value of your remainder? Is 4. Okay. In the past, the remainder theorem was used primarily to aid in evaluating polynomials, but these days, its primary justification for telling if a linear expression, a binomial term, is a factor. So by definition, x minus a is a factor of p of x, the polynomial, if p of x divided by x minus a equals a quotient, and you notice there's no remainder there. You have no remainder because it's 0. So we are going to try and see, we're going to use the remainder theorem to see if these binomials terms are actually factors of the polynomials. So remember, all you're doing is taking the factor and turning it into the root. So we're going to evaluate the polynomial with the root 3. So 3 squared minus 11 times 3 plus 24. Well, 3 squared is 9. 9 minus 33 plus 24 is 0. So P of 3 equals 0. And so that means yes, x minus 3 is a factor. Okay. What are we evaluating the next polynomial with? Example C, I'm working downwards. Negative 1. So P of negative 1 equals negative 1 in a parenthesis cubed minus 7 times negative 1 squared minus 11 times negative 1 minus 3. Reese, stand up. So negative 1 times negative 1 times negative 1 is negative 1. Minus 7 times, well, negative 1 squared is positive 1. A negative times a negative is a positive 11 minus 3. So let's see, negative 1 and negative 7 is negative 8. Plus 11 is 3. Minus 3 is 0. So this is also yes, because P of negative 1 equals 0. So it is a factor. What are we going to do for B? What are we evaluating the polynomial at? P of what? If the factor is x plus 5, good job. The root is negative 5. So 2 times negative 5 squared plus 9 times negative 5 minus 2. So I have 2 times negative 5 squared is a positive 25. 9 times negative 5 is negative 45 minus 2. 50 minus 45 is 5 minus 2 is 3. So this is a no. X plus 5 is not a factor. Okay. Are we good with that? Okay. Kane, you with us? Kane. Someone hit Kane. Okay. What about this last one? What are we evaluating this polynomial at? P of what? Positive 5. So 5 cubed minus 5 squared minus 19 times 5 minus 10. 5 cubed, 125, minus 5 squared, which is 25, minus 19 times 5, which is 95, minus 10. What do we get? Yeah, I think we get negative 5, don't we? So this is another no, not a factor. So this is where it becomes interesting. We're evaluating the function, right? And we want to know for what value of k will x minus 4 be a factor. So remember, if x minus 4 is a factor, if the remainder equals 0, which means that p of 4, when I evaluate it, has to equal 0. Okay? Does that make sense? Okay, so let's plug it in. My polynomial is, we're evaluating p of 4, and we know it has to equal 0, so I'm just going to start that off with 0 equals 4 squared plus k times 4 minus 52. So let's see, 0 equals 16 plus 4k minus 52. Well, negative 52 and a positive 16 is 36. So 0 equals 4k minus 36. If I add 36 to both sides, I get 36 equals 4k, which means that k must equal 9. What are we thinking about that?